Okay, folks, I think that I'm going to go start. This is last day 4 of the activity, and just kind of basically as a reminder again, if any of you need any professional development hours, PDH, certificate, just send me an email, and I'll get it ready and send it to you. As far as any kind of suggestions and other things, we'll have a discussion at the end of today's session, and you can submit those, as statement of needs or send by email also, to us, to Julie and me, and we'll take a look at it and then decide what's the best way to handle, R&D recommendations. Again, as a brief outline, day 1, basically I covered the strategy behind, these tools that we followed, gave you background, talked about it, and touched upon on the proof of concept early development, show you basically where the publications are from the, proof of concept development, and I showed you general features of the WaveNet first day, and then went through NDVC data buoy, basically source, and came to WIS. I showed something briefly, and then picked up on day 2. Day 2, I covered WIS, CDIP, and GLOS data sources. And yesterday, day 3, I covered GLTFS, WaveWatch 3, and with that I wrapped up WaveNet and then started TideNet. And with TideNet yesterday I covered CIRP, which is only basically water levels and tidal database, for around US, not even territory, just US. And then I basically covered also the Virtual Global Tidal Database. Today I'm going to cover the remaining 2 databases under TideNet, which are NOS data and the TPXO OSU global databases. But before I start those, are there any questions from yesterday? Okay, and we're going to have again, a QA at the end of this, and you will have opportunity to ask more questions during that session as well. As I indicated yesterday, in TideNet we have 4 data sources. CIRP tidal database, limited to the US, basically around US, East Coast, West Coast, and Gulf of Mexico, covering that. Second one is the Virtual database from France, that's global. Third one is the NOS, National Ocean Service, which is done in cooperation with the Center of Operational Oceanographic Product Services, COOP. So that's from basically a NOAA product as well. And the last one is the CPXO, which is the OSU's, Oregon State University's, Poseidon Global Model Ocean Tide. Both Virtual and TPXO use also satellite altimetry and data basically, and that gets incorporated into their basic programs, models that they run. Okay, so there's a data simulation to update and the predictions, and those are the 2 tidal databases basically that cover the world. TPXO actually uses boundary conditions from the Virtual database, to develop their thing. So the oldest tidal database that we have here is the Virtual, and quite extensive, and has been around many years, and has gone through many changes. And as I indicated, both TPXO and Virtual, they are also now extending those predictions into estuary, near coast, and even basically some embayments and things like that, for certain clients. But those kind of data basically is not available. We're just only grabbing what's publicly available. Okay. With that summary, I'm going to start today with the NOS database. So everyone can see my screen okay and hear me? Hello?
Yep.
Okay, thank you. All right. So I selected the NOS and notice that all of the NOS stations that, basically around the United States Great Lakes, right here start coming up. If I see other stations, in the territories also, Carabuis, basically we'll see those as well, I gave this. Okay? And just like with the others, these are data, measurements, point measurements, gauges, basically recording, tide information. And so I'm going to select one of the stations, here and take a look at, basically go through and show you, what we provide here. Let's start with East Coast, West Coast. Where do you like? Let's go to West Coast. Okay, let me start with this gauge. When you click a gauge for NOS, basically you will have three options, here. Access to the gauge data, which basically TideNet, is going to operate on it. You can go and view the data inventory to find out, what your data availability is from the station. And this is very useful a lot of times, because if you don't know whether data is available for that year and click, basically select the start and end times in TideNet, you may not be able to get any data, and you don't know why. But this is one way basically to go and check, availability of data. Things that you want to basically focus on here, we're looking at the water level currently. In the next phase, we also will look at the current as well. But and water level, some of data is being processed, but completely has not gone basically through QC, but they make that available as well. And the verified data comes, basically either hourly or 6 minutes, and depending on what you want, and then you can look at it, basically the times, that's available. So at this station, it started in 1999, but then there's a gap, all the way to 2002, and then a gap, and then after that, it starts pretty much 2004 and continues. Okay? So it's useful to check to do that. If you need additional information, we could also connect to, where we go and get the data and so on. And there's additional information about that platform. Okay? And a Harvest platform is one of the platforms that I work with, for the oil companies, and actually we started and paid for all of the data for NOAA to develop for it. But anyway, it's public domain now, and so you can go there and get, some additional information. There's a lot of useful information that NOS basically provides, and there are documentations and other things, that you can go and basically retrieve, from the website. And so I'm going to go select access to data. Okay. Sometime, as I indicated yesterday, also when we link to the server, basically the providers, server, the server may be quite busy or could be under maintenance or pickup and so on. Sometimes, basically you don't get any response. And if that happens, reset the map, go back, select, the same basically data source, and come and select your station again and try 2 or 3 times, If it is, basically done, then you know that it's done. You might want to wait, basically sometime in a few hours or whatever, and it will come back, usually. They do maintenance generally starting Friday afternoon sometimes, and in the weekend. The French especially do it, on Saturdays and so on. So if you go to global data, you may not be able to access their service. If you cannot get the data at all, if and try several times, then send me an email, because I have points of contact. I can contact them and see what's going on. Okay? So I access this, click the station. Notice that by default we tell you what's the latest information available, 2016, last month or so data. If you come click, basically they bring your calendar here, and you can look at it, availability of data. It says it's available from 2000 all the way 2016. Okay, so let's select 2012, and let's select maybe we get data from January 1st to March 1st. Okay, for 3 months. So if I do that, so I'm going to basically get the water level at this time and take a look at that. Okay, here's the title record that basically we have for that time period, 2012, from January 1st through March 1st. And you can look at it and zoom into sections of this if you like, to see variation in the record. You can bring your cursor in here and see the magnitude of it approximately, and at the top, basically the values will change as your cursor moves on the data file. The analysis that we do tabular data, as I said, very similar to WaveNet and other data sources that we showed. Two type of files we generate. First one is the text file for the water level time series, and I'm going to, this is a comma delimited file. I'm going to use Excel to open it. Very similar to the other data sources and data records that we process. The first column basically is time, the second column is the water level. You can basically copy these two columns and paste it in your SMS when you're generating boundary forcing water levels, for your circulation flow models. So at the top, there is record, basically says that this is generated by TideNet, station number, coordinates, datum, and start and end times. And again, just as a reminder, both in WaveNet and TideNet, we use the SI system. The second file is a file that basically we write out directly. You can bring that and load into SMS. Okay? And it doesn't know I didn't assign any opener to that, and so I'm going to open that. There's a header information on that file so that for SMS to understand. This is the XYS type of file format that SMS understands. And it says there are two columns. There are 1441 basically records in it, and this tells basically type of file characterization that SMS needs to know. Okay, so the second thing that we provide is the time series plot of the water level versus time. And this is ready basically for you to go and take it and put it in your report document, whatever you want. So, but you also have that Excel file, CSV file, that you can save it. Any file, as I said, is savable. If you put click, right mouse click, save link as, and then it comes and gives you basically, in this case, a PNG file. In the previous one, it will be a CSV file. Store that and save that in your local machine. Don't leave it on my server because I run scrubbers, it will be gone after a day or two. So if you want to keep your records, just save your information on your machine. Next thing that we do, we analyze the data and provide the constituent information. Again, it's needed for numerical models. It took a while to operate on it, but it should provide us a list of constituents. For the NOS data, we provide almost all available constituents that are available to be consistent with the data source. That's what NOS does, and that's why we do that. Otherwise, typically we'll provide only 6 major constituents and 2 minor, basically M2, S2, N2, K1, O1, and that kind of thing. And but because NOAA provides the other constituents as well to be consistent with them, we just calculate all of them, also provide that. You're going to need probably in SMS only maybe about 6 of these or whatever, depending on your model, what it calls for it. That's a HTML file, and there's a corresponding, basically Excel file, CSV file, and you can copy from here, the columns and values of it and paste it to your SMS to define the boundary forcing for your circulation flow model. Next operation we perform is the histogram, generate the histogram for the water level, number of occurrences for each of the basically value of the water level, and standard 1D type of basically histogram that sometimes is very useful to look at it. Okay. The last basically operation we do on the data are the statistics. Did I click it? Yeah. Okay. So the statistics tells you that this is generated by TideNet, station number, left longitude, start end times, and first order level statistics. The datum is mean low water basically, and standard deviation, mean value, max and minimum values at the time that they occurred or whatever, and the median and the number of counts in the data, and no gaps in that particular data in this case. And again, this is an HTML file and corresponding Excel file. It has same information, and you can open that, basically. It's slow. It's not there. Okay. It's just slow. I don't know why, but okay. So same information is given right here as well for you to keep it whichever you like. Some user requested in this format, some like in HTML format, whichever you like with that. Okay. So that's for one of the basically NOS stations. And all stations work same way. For example, if we want to take a station and let's go to maybe Hawaii, right, island, and look at the Hilo station. So in this case, I'm just going to grab, whatever the last month, 2016 data, and but identical. There's no difference what I'm saying, So that's the last month data that was recorded by the page at the Hilo. And the procedure process, basically, analysis that we apply, are identical, to the other station. So this kind of covers basically the NOS. Next, I'm going to go to the OSU's TPXO, the global tidal database. Again, CIRP, Le Provo, and TPXO are tide basically information calculated by numerical model, which means that, they are gridded data. So in order to operate or request, data for those, you need to tell basically TideNet a location where you are interested to have the information. Okay? So that means that you need to click somewhere on this map and say that, okay, I want to tide, basic information at this point. As soon as you click that, it tells what the coordinates are at the bottom right here, and the availability of data, and then you can go look at it and where the data is available. It says from 2000 through 2016. And let's go to, let's say, 2005. And let's see if we can get data maybe for about a year. Okay. And notice that as soon as I click 2005 1231, automatically it set this to 2015 1130. About we try to get the data for 1 month. That's because some of this data sources limit the data download to 1 month and that kind of thing, but that's the default. But you can override it here. So I'm going to try to request the data for 1 year instead of 1 month. And see if it basically is going to be able to grab it. Bingo. Okay? So quite fast. Depends on the data source and the basically host server that we're handshaking with, and loading basically how many people are using, and so workload basically both on your side as well as the basically provider side determines the speed that you're going to be able to retrieve the data. Let's take a look at the tabular data. And again, two types of files generated, one for SMS and one basically for you to save into your local machine. Very similar to format is almost identical basically to the OSU data that we looked at it, NOS data, NOS, and so column 1 time, column 2 is the water level. And again, everything is SI units. This is SMS prepared file so that you can load. Sometimes people prefer that, and they can go and basically operate on that data and couple tie to their numerical model inside SMS if they'd like to. We did this because sometimes our CMS flow guys basically like this rather than copy and paste so if some other models basically can use this, then it will be available in SMS, and you can directly port this file as a boundary condition to your numerical model. Next, the plots for you for your records, and again, maybe too crowded. You might want to thin out, basically look at, portions of it, and whichever. But you have also the CSV file, Excel file, and you can plot it in portion segments, the data any way you like. Okay. The constituent analysis will provide the constituent report, and that is, as I said, we provide M2 default, S2, M2, K2, K1, O1, P1, and Q1. Okay? And if you need more constituents or whatever, you have the data, and either can do your own analysis or let us know if there's need to add additional constituents. We can populate this is what I'm saying. But this is generally what is required, for you to input into SMS, as far as the constituent-driven, boundary conditions, specified boundary conditions. Histogram plot is very similar. 1D basically plot, number of recurrences and for each of the water level, bins, and centered around 0, 0.2, and so on. Distribution of the basically water level. And the last is the statistics of the basically tide for that time period, and again, minimum and maximum recurrence times, and these are critical to, again, for ship passage, port operations, and so on, and we provide that information for that very purpose. Some users may not need it, basically, but if there is some other information that, you think that you will need, then you can provide, basically your feedback, and we can try to add, that information as well. Okay, that's pretty much wraps up for me, both the WaveNet and TideNet. So at this point, I'm going to open the floor to questions, discussions, suggestions, anything that basically you have with respect to TideNet as well as the WaveNet. I think this is the time to talk about and express your needs and suggestions, and then Julie, program manager, basically will take a look at basically your request. Maybe you can submit them either statement of needs or other ways, depending on the nature of the need, So, all right. Any questions?
Hey, Zeki, this is Julie. So maybe it would be kind of fun to review some of the other comments that have come in through the week. And I had a couple written down from the very first day. One was about the histogram. These are both from Rod Moritz, I think, from Portland District. And he said the histogram, there were different ways of presenting that, and he said, well, for that particular one, he suggested adding the total number of occurrences. And maybe you could just pull up that plot so that everybody could see it. And the reason I'm kind of summarizing these things that Rod said is maybe they'll spark some other discussion or conversation about other needs or what other people think about these. But can you bring up one of those? I think that was under TideNet, WaveNet, and it was a histogram of the wave occurrences for any of them, I think. Yeah, I don't think it really mattered. And his suggestion was that it shows, here we go, yep, it'll show so what you see, the number of occurrences on the right axis, the right vertical axis, but you don't know how many total there were. Like maybe there were 4 billion and there were some calm periods or something like that, but you don't really see that. So his suggestion was, can you add the total number of occurrences somewhere on this plot? And I think he responded that, yeah, that'd be something that was relatively easy to add.
Well, in fact, we do some of those in some data sources and even have fractional numbers here because of that, but yeah. But I think that we need to put the total, indicate total, and then normalize.
To discuss, if you just put like the percentages there, as Zeki was just saying, that it's such a small number, it doesn't make sense at all.
Yeah.
So it's more informative to have 480 there as the top greatest number, but also include the total occurrences in the data set.
Yep, no problem.
Yep. So that's a good one. And then the other thing he mentioned was about binning the data, and I didn't quite follow this. You and he had a conversation then about it, and I think you had done something a little bit different in binning the data for a study you did for them, I think on the Columbia River, but I didn't really follow exactly what he was getting at.
Yeah.
I think what he said was something like, well, sometimes there's rare events, and it's really difficult to see those and to highlight that those rare events may be the ones that really make a difference in terms of change, morphologic change or even hydro change within your system, that it's difficult to show those on this plot. And he thought, well, maybe that would be some area of research that the field could kind of think about how to do that a little bit better.
Yep. Both the histograms as well as the scatter plot, there are at least 4 or 5 different ways, presenting them, constructing them, and each of them basically, I think you can glean some information from them. But if we maybe we will make optional, put options in the histograms and so on, as 1D, 2D, color, non-color, normalized, non-normalized. We can put those kind of options, and then user can generate any of those types, what I'm saying, We have software that does that, but we just basically decided on this based on we thought that, the most useful ones, but he wants, some other ones, we can add those, populate those. Some of them will require the color coding that we did, in the MCR design study. Those are quite involved because they were zooming on extreme storms, rare events, and so on. To do those, then you have to take the wave height bins, 0 to 2, for instance, operate on that data in more detail, do some other type of analysis. That way, you can see whether, that is an event that, you want to really consider, for the design, maybe 5-year design, 10-year design, and so on. So it has a relationship, my point is, to the return period that, user needs to, or is considering, to design the system for. So there's these plots, what I'm saying, and they can be very useful, providing information that, you need to select, basically the return period, associated events, also correctly.
I see. Is that something like within WaveNet, could you potentially have a plot? You could say this might be useful if you're looking at a 5 to 10 year return period, and you could have you might want to look at.
Well,
so do you look at this kind of plot or something like that? I don't know.
Yeah, I'm going to send him some table, things like that I've done for all companies, that's what his interest is. He wants to know, for instance, for 5-year, return period, what is the parameters I need to use? And for 10 years, for 25 years, for 50 years, 100, 250 years. He wants to synthesize this data a little bit more in detail, given some more guidance, on toward the design and selection of the basically return period, for design that he needs to consider. Maybe he needs to go, basically to a 50-year design as opposed to a 25-year design. But if he sees that information, then he can make some judgment. So, I think I'll probably, share some stuff with him, and maybe, then based on his recommendation, we'll go from there. So we're going to add, obviously, some of things, but we want to know who wants what type of thing, and that's the time, opportunity for you guys, to raise your voice and say that, how about this, we need this made here, or so on, and that kind of. My suggestion is, again, really just on, your recommendation and put it, maybe send it to Julie, and then we can decide whether, it's something that can be considered quickly without going through the statement of needs, or should be considered as part of the statement of needs. Because all of the R&D is supposed to be now kind of based on the statement of needs type of thing, looks like it. So if it requires a little bit of research work, I think that we have to configure, the needs in that form.
Yep.
Okay. Any other questions, suggestions? Now, Matt sent me some, his plots, 1D plots and other plots that he has done. I'll take a look at it, and he's the new employee, basically, right? Matt, are you there?
Yeah, I'm the new guy.
Yeah, at Los Angeles district, and so he's doing some analysis also using basically similar tools, so, and those are the type of things that, basically we need to communicate with the field people, as what their specific needs are, and use those, what I'm saying, rather, I can go ahead, a lot of things, that I think that should be added, but I didn't want to do that personally. I want to basically, this should be field-driven, and USACE-driven type of thing, not, basically what I think they should be going there. So that's why I'm open to any suggestion coming from field people, listen to those first and that kind of thing, and then maybe I'll get back to you, you guys, and say that, how about this? Do you also need this or not? And that kind of thing. That's the way that I was basically hoping that we proceed.
Zeki, what's next after WaveNet and TideNet? Are there any other modules
Well,
you see?
this system, when really original basically plan that I submitted, it has other modules. One of the modules, again, was based, this system is based on course operations needs, planning, and when I submitted it and made a presentation on this at the IWR, it was late 1990s. All the SES guys, the operations guys, even inland guys, they beg basically a system like this, but not only just coastal, but that provides them also inland, waterway, navigation issues, this and whatever. So one guy from Omaha district, I forgot his name, but anyway, he was saying that, well, if my territory, they just covers, let's say between point A and point B, and I need to be able to provide basically, people, my state, users, basically in that area, questions related to, is it safe or to go, let's say, from St. Louis to Rock Island, okay? What are the conditions, can you give me some wind information, visibility information, current information, this or whatever? And I kind of showed him basically a system that we do for port operations and bring in tankers and this and whatever, to, Texas, Louisiana, and so on. Again, for, offshore industry and that kind of. Basically, they said we need similar things, except basically for a different purpose, for inland navigation and that kind of. So I suggested something called RiverNet, okay, or whatever you want to call it, but the inland waterways and navigation aid, again, that will provide them whatever information that's critical, to their operations. And we can provide them, as I said, the wind information from airports, this or whatever. We can tap, into National Weather Center, the service, right? On your TV, you turn the TV on, basically we'll go to Weather Channel. That's what they do. That's, they're on basically this numerical model. They have those fields for you. And we should be able, what I'm saying, to provide, that kind of information. And the district needs to be able to answer any, there's a request comes, this or whatever, for their planning. They need to know what is the typical monthly, condition, maximum worst condition between, these two basic, routes, and that way, basically the traffic, the commerce, the trade, can be, managed, properly. So that was one module, okay? I call it RiverNet. But the other thing that is critical for that river, we have to tap into USGS gauges, okay, for water levels, right? River discharges and so on. So that requires a development, But once, basically we learned all of this stuff for, WaveNet and TideNet, then the next, basic program hopefully can, piggyback on a lot of knowledge and utilities and so on that we have from here and apply that, to the USGS stages and so on. But we also need to draw, as I said, from the airports, nearby and so on, from the numerical models, basically, and both waves, currents as well as the, water levels and winds and so on. So that's one module. The other module that basically was kind of requested, they wanted to have the geospatial data. A module that basically brings for their area navigation operations, even they said, for like lakes and dams and things like that, where, basically I can pull it and see everything, whatever infrastructure is there, and so on. But I don't know whether in the Corps of Engineers, Julie, there's someone doing that geospatial data. I think that my understanding was Jeff Willicraft didn't want us to touch that, and because LiDAR Center and others, basically are trying to assemble that kind of information. But what these people, operation people and so on, planning people were asking, they say, well, but I need something that's simple, pulls all of this and gives me information I need. I don't have time, people, each time I don't need to go to a R&D center, to get this type of thing. A tool like that would be very, very useful for us, to do quick day-to-day type of, things, planning things that we do, and economic studies that we do and that kind of thing. So, but that was, a geospatial module was basically for that also. And in the geospatial module for coastal, I was hoping that if this is your study area, you go there and assemble all of the basic bathymetry, right? Shoreline information, a harbor basically layout, infrastructure information, and this or whatever. So you need to draw from existing data sources. So these tools, need to tie in or grab, information from cores, basically, databases that are developing those things. And plus, like if you're going to a port, obviously you need to go to, Hilo Harbor basically, or Los Angeles or whatever. They have, some of the information, on their websites and their, databases, and grab, from that. So it was basically a modular system like that that was requested, and we started just with WaveNet and TideNet and limited it that to, coastal only so far. But the other two, basically have not been, addressed, tackled yet. Depending on the request, I mean, if there is need, and district says that, yes, we need this or whatever, then those can be also basically considered.
There are also two requests. One's for the real directional wave spectrum, because CIRP and NTPC, they kind of switch now to the full spectrum measurement. So they have the real measurement. It's good for sometimes the deep state. You have a multiple wave come from different directions. Well, those are usually use parameter, you generate those idealized wave spectrum. It doesn't really show that one. So there's a request, we can maybe in the future touch that subject. The other one is the field of wind, the field of pressure, because basically for some models, you really require the spatial input, the wind field. So that's something we may think about, how we can really, get into our system.
Yeah. I do want to
just to follow up with Realize, what data sources do the full spectra and then the wind pressure?
Okay. So if you come here, for instance, in the WaveNet, so in the next phase, hopefully, let's hope, they will provide 2D spectra, okay? It's not available, but, and same thing, when I talked to, for instance, Henrik told me, developing, basically wave-watch tree and GLCFS, they are going to provide basically the 2D spectra. I already get 2D spectra from some military works, but it's not available civil works yet, and that kind of thing, but plan is to provide those. And likewise, CIRP, you know, and again, CIRP already does. I mean,
Okay.
yeah. And so in the next basically phase, you know, addition, you know, to WaveNet, what I'm saying, in addition to the wave parameters, then we must basically add, you know, the two-dimensional spectra when these sources start providing those. But we're waiting on them. CIRP is the only one that basically has it right now. Is that right? Yes, sir?
Yes.
Okay. So NDBC and CIRP, basically we can start, you know, with that, you know, maybe next FY and add, you know, that. And when WISP, you know, becomes available, we'll grab at that. And same with the WaveWatch 3 and GLCFS. So those are additions, okay? The wind fields, currently Core buys basically wind fields for their project most times from ocean weather, you know? Yeah, ocean weather, you know? Yeah. But there's also public domain, you know, wind fields, okay? And most projects that basically Levi and I have done in the Chesapeake Bay, for instance, I didn't want to spend, you know, $70,000 for per station data, you know. We just grab, you know, free data, you know, basically that's available. And so we can start, what I'm saying, providing the basically, you know, spatial, you know, wind fields. So this is not a point measurement, Julie. You know, these are, you know, covered, you know, the entire Chesapeake Bay or whatever, you know, right? And so those wind fields are very useful because otherwise we have to run like, you know, planetary boundary models or something like that to generate the wind fields that, you know, goes into, right? For me to do something, let's say, in the South China Sea or whatever. Well, but if the wind field is available, someone has generated, why should I do that, right?
Yeah.
Save me a lot of time and money and that kind of thing. And so those are the additions that, you know, that should be considered, you know, to, you know, expand the capabilities already that are here, but those are additions, okay? But the new modules are completely different story.
Yep. Okay, thanks.
Mm-hmm. Anything else? Don't be shy, ask questions. But if you want to write your comments, this or whatever, take your time and talk to, you know, your coworkers, your, you know, branches, you know, in the district, you know, basic people, others, you know, that you work with, and come out with some, you know, wish list, if you wish, you know. That's fine. That's fine. Just submit those, you know, send to Julie, you know, and let's take a look at it, you know, basically, and how do they fit into short-term, long-term, whether they are R&D type of thing or these are can be considered, you know, with the, you know, present, you know, versions, you know, of the tools, you know, or require new tools or whatever. We'll find out, yeah. Okay, and as I said, you know, if you need any PDH, you know, professional development hours, just send me an email and say that I attended 2, I attended 1, 3, 4, or whatever, you know, and then I'll basically prepare a certificate for you guys that, you know, some of you guys need. Okay? Well, thanks for attending, and again, we're here, and if you have any questions right after this, go play with it. And I'm sure that you probably will have some basically questions and encounter something, this or whatever. Just contact Liwa or me, you know, and we'll address, you know, basically any technical questions. No problem. I appreciate you guys, you know, participating. Oh, we're going to put all of these are being recorded by the videos. The videos, you know, will be on CIRP website under those, you know, trainings, you know, and so we'll post those, you know, there so that you can go back and watch and listen, you know, basically, and if anyone else in your district basically you think that, you know, they can benefit from it, just tell them, you know, where they're at so that they can go in and, you know, look at and go through the, you know, videos. Thanks again. Have a great day.